When humans are gone, what animals might evolve to have our smarts and skills?
当人类消失后，哪些动物可能会进化成拥有我们的智慧和技能？
Planet, apes, Earth.
行星、猿类、地球。
Is this a planet of the apes situation?
这是人猿星球的情况吗？
Humans are pretty unique among life on Earth.
人类在地球上的生命中非常独特。
Species, evolve, intelligence.
物种进化智力。
As far as we know,
据我们了解，
we're the only living species to evolve a higher intelligence.
我们是唯一进化出更高智慧的生物。
Wear clothes, cook our food.
穿衣服、做饭。
Invent smartphones and then get locked out of them when we forget our passwords.
发明智能手机，然后当我们忘记密码时就会被锁在外面。
Extinct, societies, evolution.
灭绝、社会、进化。
But what if humans suddenly went extinct?
但如果人类突然灭绝怎么办？
What other animals might evolve to have the smarts and skills to create large, complex societies like we have?
还有哪些动物可能进化成拥有智慧和技能来创造像我们这样的大型复杂社会？
With modern gene sequencing technology and our understanding of evolution,
凭借现代基因测序技术和我们对进化的理解，
we're pretty good at making short-term predictions.
我们非常擅长做出短期预测。
Martha Reiskind, a molecular ecologist at North Carolina State University, told Live Science.
北卡罗来纳州立大学的分子生态学家 Martha Reiskind 告诉 Life Science.
Predict, extinct, climate.
预测灭绝气候。
Drought, resiliency, survive.
干旱恢复力生存。
For example, we can predict that if humans were to suddenly go extinct tomorrow,
例如，我们可以预测，如果人类明天突然灭绝，
climate change would continue to drive many species toward drought resiliency in order to survive.
气候变化将继续推动许多物种适应干旱以求生存。
Struggle, polar bears, penguins.
奋斗北极熊、企鹅。
Thrive, millennia, continue.
繁荣千年继续。
Cold specialized species will continue to struggle as well.
寒冷特化物种也将继续挣扎。
Meaning that, sadly,
意思是可悲的是，
polar bears and penguins are unlikely to thrive in the millennia after humans are gone.
在人类消失后的几千年里，北极熊和企鹅不太可能繁衍生息。
Geologist, speculative, convergence.
地质学家推测收敛。
A big thing will be the concept of convergence.
融合的概念将是一件大事。
Dougal Dixon, a geologist, science writer and author of the speculative book.
Dougal Dixon, 地质学家、科学作家和推理书的作者。
After Man. A Zoology of the Future. St. Martin's Press, 1998, told Live Science.
在人类之后，未来的动物学，圣马丁出版社1998年告诉 Life Science.
Unrelated, organisms, traits.
无关生物特征。
Succeed, fill a particular niche.
成功填补一个特定的利基。
Convergence is an evolutionary process.
收敛是一个进化过程。
By which two unrelated organisms end up developing similar traits in order to succeed in a particular environment or fill a particular niche.
两个不相关的生物最终会发展出相似的特征，以便在特定的环境中取得成功或填补特定的位置。
The classic example, Dixon said, is the fish shape.
迪克森说，经典的例子是鱼的形状。
Sleek, torpedo-like bodies, stabilizing fins, optimize.
圆滑的鱼雷状的身体稳定其优化。
With their sleek, torpedo-like bodies and stabilizing fins, fish are optimized for life in water.
凭借其光滑的鱼雷般的身体和稳定的鳍，鱼最适合在水中生活。
Dolphins, similar body plan, warm-blooded.
海豚类似体型，温血动物。
However, dolphins have evolved a very similar body plan.
然而，海豚进化出了非常相似的身体结构。
And unlike fish, they are warm-blooded, air-breathing mammals.
与鱼不同，它们是温血、呼吸空气的哺乳动物。
With a totally different evolutionary background.
有着完全不同的进化背景。
Feature, spatial, uniquely, dexterous.
特征，空间，独特，灵巧。
Uniquely good at building and spatial.
独特的擅长建筑和空间。
One feature that makes humans uniquely good at building and spatial reasoning is our dexterous hands.
使人类特别擅长建筑和空间推理的一个特征是我们灵巧的双手。
According to research from the University of Manchester.
根据曼彻斯特大学的研究。
Ecological, similar capacity, manipulate.
生态相似能力操纵。
In order to fill the same ecological role as humans.
为了填补与人类相同的生态角色。
That is, building cities and heavily modifying our environment.
也就是说，建设城市并严重改变我们的环境。
Another species would need to develop a similar capacity to manipulate objects.
另一个物种需要发展类似的能力来操纵物体。
In other words, they would need opposable thumbs.
换句话说，它们需要相对的拇指。
Or at least thumb equivalents.
或至少拇指等价物。
Opposable thumbs. Chimpanzees, bonobos.
对生拇指，黑猩猩，倭黑猩猩。
Other primates, like chimpanzees and bonobos.
其他灵长类动物，如黑猩猩和倭黑猩猩。
Our closest living relatives already have opposable thumbs that.
我们在世的最亲近的亲戚已经有了对生的拇指。
They used to make tools in the wild.
它们用来在野外制作工具。
It's possible that if humans go extinct.
如果人类灭绝，那是有可能的。
These hominids might replace us hominins, planet of the apes.
这些原始人可能会取代我们人类，人猿星球。
Precedent, overlap, outlast.
先例，重叠，最后。
Managed to outlast. Neanderthals, there is precedent.
设法熬过尼安德特人，有先例。
There is precedent for that. Kind of overlap.
这种重叠是有先例的。
After all, our species managed to outlast the intelligent Neanderthals.
毕竟，我们的物种比聪明的尼安德特人活得更久。
During the most recent ice age 40,000 years ago.
在4万年前的最近一次冰河时期。
According to a 2021 study published in the journal Nature.
2021年发表在《自然》杂志上的一项研究。
Apes, sophisticated.
原，复杂。
That said, it would probably take hundreds of thousands or even millions of years of evolution for other apes.
也就是说，其他猿类可能需要数十万甚至数百万年的进化。
To develop the ability to create and use sophisticated, human-like tools.
培养创造和使用复杂的类人工具的能力。
Scenario: Common ancestor.
情景：共同祖先。
To add context to this scenario, the common ancestor of modern humans and chimpanzees lived about 7 million years ago.
为了给这个场景添加背景，现代人类和黑猩猩的共同祖先生活在大约700万年前。
Live Science previously reported.
Life Science 之前报道过。
Disaster. Potent enough. Wipe out, candidate.
灾难足够强大，消灭候选人。
But any disaster potent enough to wipe out humans is also likely to wipe out chimps.
但任何足以消灭人类的灾难也可能消灭黑猩猩。
Which leaves another tool using candidate to fill humans' niche: birds.
这留下了另一个使用工具的候选者来填补人类的利基：鸟类。
Non-avian, dinosaurs, extinct, vacant niches.
非鸟类恐龙灭绝空位。
When non-avian dinosaurs went extinct 66 million years ago.
当非鸟类恐龙在6600万年前灭绝时。
Mammals rose to fill many of their vacant niches.
哺乳动物崛起以填补它们的许多空缺。
Handiest. Land animals, disappear, surviving.
最方便的陆地动物消失幸存。
If humans were to disappear.
如果人类消失。
It's possible that birds.
有可能是鸟类。
The only surviving dinosaurs.
唯一幸存的恐龙。
Could fill our roles as the smartest and handiest land animals.
可以填补我们作为最聪明和最灵活的陆地动物的角色。
Stereotypes. Contrary, brainy.
刻板印象，相反，聪明的。
Despite stereotypes to the contrary.
尽管有相反的刻板印象。
Birds are very brainy.
鸟类非常聪明。
Some birds, such as crows and ravens.
有些鸟，比如乌鸦和乌鸦
have intellects that rival even chimps.
拥有甚至可以与黑猩猩相媲美的智力。
According to research published in 2020 in the journal Science.
根据2020年发表在科学杂志上的研究。
Dexterous. Beaks, wire.
灵巧，会线。
And some birds can use their dexterous feet and beaks to fashion wire into hooks.
有些鸟可以用它们灵巧的脚和会把铁丝做成钩子。
According to a famous 2002 study published in Science.
根据2002年发表在科学杂志上的一项著名研究。
Meanwhile, trained African gray parrots, Psittacus erythicus, can learn upward of 100 words and do simple math.
同时，受过训练的非洲灰鹦鹉可以学习多达100个单词并进行简单的数学运算。
Including understanding the concept of zero, Live Science previously reported.
包括理解零的概念 Life Science 先前报道。
Birds can flock together in large groups, and some, such as sociable weavers, Philopteris socius.
鸟类可以成群结队地聚集在一起，有些，例如群之雀
even build communal nesting sites.
甚至建立公共筑巢地点。
Decades. Occupied, sociable, nests.
几十年，占用，善于交际，巢穴。
Some sociable weaver nests remain occupied by birds for decades.
几十年来，一些群之雀巢仍被鸟类占据。
According to research published in the journal Frontiers in Ecology and Evolution.
根据发表在《生态与进化前沿》杂志上的研究
However, these arboreal dwellings wouldn't look much like human metropolises.
然而，这些树栖住宅看起来不像人类大都市。
Adept, limbs, influence.
熟练，四肢，影响。
But there is another group of animals that
但是还有另外一组动物
is extremely adept at manipulating objects with their limbs, all 8 of them.
非常擅长用四肢操纵物体，所有8只。
Intelligence is modifying your behavior as a result of influence from your environment.
由于环境的影响，智能正在改变你的行为。
Jennifer Mather, a cephalopod intelligence researcher at the University of Lethbridge in Alberta, Canada, told Live Science.
加拿大艾伯塔省莱斯布里奇大学的头足类动物情报研究员詹妮弗·马瑟告诉 Life Science:
Distinguish octopuses, virtual.
区分章鱼，虚拟。
By that measure, octopuses are probably the smartest non-human animals on Earth.
按照这个标准，章鱼可能是地球上最聪明的非人类动物。
Engineer, unwanted, algae, dens, barricading.
工程师，不需要的藻类、巢穴、路障。
They can learn to distinguish between real and virtual objects.
他们可以学会区分真实和虚拟的物体。
According to 2020 research published in the Biological Bulletin.
根据2020年发表在《生物公报》上的研究。
And they can even engineer their environment by removing unwanted algae from their dens and barricading the entrance with shells.
它们甚至可以通过从巢穴中去除不需要的藻类，并用贝壳封锁入口来改造它们的环境。
According to a study in the journal Communicative and Integrative Biology.
根据 Communicative and Integrative Biology 杂志上的一项研究
Of sorts, communities, different, adapt.
各种社区不同，适应。
They're even known to live in communities, of sorts, as shown by the discovery of Octlantis off Australia.
众所周知，它们甚至生活在各种社区中，正如在澳大利亚附近发现的 Octlantis 所表明的那样。
Related. How would Earth be different if modern humans never existed?
相关，如果现代人类不存在，地球会有什么不同？
However, octopuses would be hard-pressed to adapt to life on land.
然而，章鱼很难适应陆地上的生活。
Oxygen, vertebrates, binds.
氧气，脊椎动物结合。
Vertebrates have iron in their blood cells, which binds to oxygen very efficiently.
脊椎动物的血细胞中含有铁，可以非常有效地与氧气结合。
In contrast, octopuses and their relatives have copper-based blood cells.
相比之下，章鱼和它们的亲戚有同基血细胞。
Molecules, confined, oxygen-saturated.
分子，受限的，氧饱和的。
Less readily, molecules, confined.
不太容易，分子，受限。
These molecules still bind to oxygen, but less readily.
这些分子仍然与氧气结合，但不太容易。
And as a result, octopuses are confined to oxygen-saturated waters as opposed to thin air.
结果，章鱼被限制在氧气饱和的水中，而不是稀薄的空气中。
Inefficient, metabolism, as far as they can.
低效代谢，尽其所能。
They've taken an inefficient metabolism as far as they can go, Mather said.
他们已经尽可能地进行了低效的新陈代谢，马瑟说。
Transition, impactful, mantle.
过度有影响力地幔。
Because of this, Mather thinks that
正因为如此，马瑟认为
octopuses and other cephalopods are unlikely to make the transition to land.
章鱼和其他头足类动物不太可能过渡到陆地，
and take over humanity's mantle.
并接管人类的地幔。
As the smartest and most ecologically impactful land animal.
作为最聪明和最具生态影响力的陆地动物，
Her money is on social insects, like ants and termites.
它的钱是在社会昆虫上，比如蚂蚁和白蚁。
Insects, tougher, cephalopods.
昆虫更坚韧，头足类。
I think that the insects are tougher than us, Mather said.
我认为昆虫比我们更强壮，马瑟说。
Unfortunately, they're tougher than cephalopods as well.
不幸的是，它们也比头足类动物更坚韧。
Incredibly, adaptable, different.
难以置信，适应性强，不同。
Here's why. Insects are incredibly adaptable to different types of environments.
原因如下，昆虫非常适应不同类型的环境。
They have been around for 480 million years.
它们已经存在了 4.8 亿年。
According to the Natural History Museum in London.
根据伦敦自然历史博物馆的说法，
Niche. Imaginable, burrowing, elaborate.
利基可以想象，挖洞，详细。
In that time, they've evolved to fill almost every niche imaginable.
在那段时间里，它们已经进化到几乎可以想象到的每一个细分市场。
From flying to burrowing to swimming and even building elaborate city-like towers.
从飞行到挖洞再到游泳，甚至建造精致的城市般的塔楼。
Termite colonies, resembles, civilization.
白蚁群，类似文明。
The organization of ant and termite colonies probably resembles human civilization.
蚂蚁和白蚁群体的组织可能类似于人类文明。
More than any other non-human species on Earth.
比地球上任何其他非人类物种都要多。
Communicate, inside, vibrations.
沟通，内部震动。
Ants are known to farm fungi.
蚂蚁以种植真菌而闻名。
According to research published in 2017, the journal Proceedings of the Royal Society B.
根据2017年发表在英国皇家学会会刊 B 上的研究，
And termites can communicate over long distances inside their colonies using vibrations.
白蚁可以通过震动在它们的群体内进行长距离交流。
According to a 2021 study in the journal Scientific Reports.
根据科学报告杂志2021年的一项研究，
Insect colonies take over.
虫群接管。
If humans go extinct.
如果人类灭绝，
It's possible that these insect colonies might take over the world.
这些昆虫群落可能会接管世界。
Assuming they survive climate change.
假设它们在气候变化中幸存下来。
Of course, all of this is speculation.
当然，这一切都是猜测。
Geologic, unfold, predict, evolution.
地质展开预测进化。
It's virtually impossible to truly predict how evolution will unfold on a geologic timescale.
几乎不可能真正预测演化将如何在地质时间尺度上展开。
As you go further and further out, your precision is less clear.
随着你走得越来越远，你的精确度就变得不那么清晰了。
Because there's all these other wonderful things that cause variation, Reiskind said.
因为还有所有其他奇妙的事情会导致变异 Reiskind 说。
Population, bottlenecks, brink, extinction.
人口瓶颈边缘灭绝。
Those factors include random mutations, sudden extinction events and population bottlenecks.
这些因素包括随机突变、突然灭绝事件和种群瓶颈。
In which a species pulls itself back from the brink of extinction.
一个物种将自己从灭绝的边缘拉回来。
But loses much of its genetic diversity.
但失去了大部分的遗传多样性。
And it's even more difficult to predict.
而且更难预测。
Whether another species will develop human-level intelligence or the desire to build cities.
另一个物种是否会发展出人类水平的智力或建造城市的愿望？
Mather thinks that it could happen.
马瑟认为这可能发生。
But not without millions of years of the right selective pressure.
但并非没有数百万年的正确选择压力。
Dixon, however, is less optimistic.
然而，迪克逊则不那么乐观。
I don't think nature will make that mistake twice, he said.
我不认为大自然会犯2次这样的错误，他说。
I don't think nature will make that mistake twice, he said.
我不认为大自然会犯2次这样的错误，他说。